So I had a few questions on number 28 from 6.3. So if you can have your books out, because I didn't do the greatest at the graph. So it's page 369, number 28. The question is, let me read it. If the region shown, this region here, is rotated about the y-axis to form a solid, use the midpoint with n equals 5 to estimate the volume. So what happens is if you take this region and you rotate it about the y-axis, you get something like this, which is off the screen, and you'd have this empty space here. Well, once you formed this solid, we would be using the shell method. Now the formula for the shell method is the 2 pi times the radius times the height times dx. Okay. So what we would do is we would draw a typical shell. Okay. So draw a typical shell. Okay. And then we would find the radius of the shell. The radius is the distance from the axis of revolution out to this point. And then the height would be the distance from here to the point, so that would be my y value. And then we would find that function and integrate it. But problem is we have no function. There was no function explicitly written. They just gave you the graph. So there's not going to be a formula for us to find, or a function for us to find and integrate. So we're going to have to do it a different way. Oops. So what we're going to do is use the midpoint rule. Now the midpoint rule was used back in chapter 5 as a way to estimate the area under a curve. Now the way that it worked is you would take, I believe they gave us n equals 5, you would find dx. Now dx is the width of each rectangle, and that was b minus a over n, which I believe is 2 and 12. 12 minus 2 over 5, which is 2. And then what we would do is we would, let's get a different color here. We would take rectangles that have a distance or a width of 2 and find the area of these rectangles. But with the midpoint rule, the way that this worked is we would take this rectangle but use the middle point of the rectangle to form the y value. So in this rectangle here, this is the midpoint, you would use the middle number, okay, to find the area. And then we would add up all of these areas. That's how we'd use the midpoint. But now instead of little rectangles, 5 of them, we're going to have 5 shells. So our first shell, let's take a look at our first shell. So it's going to have a width of 2, and so we're going to use the midpoint, which is right there. There's my y value. All right, so this is our first shell. Okay. And we would need, so let me just call that, I'll just say first shell. And we'd have to find the volume of this. Now the volume of each shell is 2 pi radius times height times dx. Okay. So in this case it's 2 pi. Now the radius is the distance from the axis of revolution to my point on the graph. That's 3. And the y value is f of 3 times dx. Let me just write, I'm sorry, delta x. Let me just write delta x. So that's 2 pi times 3. F of 3, I believe, is 2. Delta x is 2. So that's 24 pi. Alright, so that's the volume of the first shell. Now you just have to do that for all the remaining 4 shells. So you'd have a shell right here, Here's the midpoint. So draw that line up. And so then you would have a shell there. Okay. And so the radius would be the distance from the axis of revolution out to here. So that would be your radius. You'd have a height value, which is f of 5, and multiply by dx. So just do that for each shell, and you should have a total of 5 shells. And that should be it. So I hope this helps. If you have any questions, just send me an email. Okay, this was just a follow-up to a question, another question that someone asked about this, number 28 from 6.3. We were finding 5 shells, and we were adding up the volume of the shells to get the total volume, or the estimate of the volume of the solid. If we went back and we just did a typical shell, back if we were just doing this a normal 6.3 problem, which the volume was from A to B 2 pi radius times height, you would notice that the interval is going to go from 2 to 12. The radius is always the distance from the axis of revolution out to my point. Now, because everything has to be in terms of x, and this distance here is represented by x, then the radius is just x. Okay. And then the height would have been f of x. I don't actually have a function for f of x, but this is f of x times dx. So this is what we're integrating. Now, if you go and find the midpoint, find delta x first, which was b minus a over 5, which I think we already said was 2. The midpoint is going to be this, the way we would use the midpoint. And the follow-up answer, my follow-up response to somebody's question was, let me write this down first, f of x dx. So that would be the area, or the volume of shell 1 plus the volume of shell 2, and so on. So that's going to be 2 pi, I'll call this x1 f of x1 times delta x. That's the volume of shell 1. Then you'd have 2 pi x2 f of x2 delta x, and you do that up 5 times. Now, a couple minutes ago, we found just the volume of shell 1. So if you want to know what your x's are, let me scroll up a little bit. Besides drawing in your shells and saying, okay, if this is 2 and this is 4, then I know that my midpoint is 3. You can find all the midpoints first. So we'll have 1 at 3, 1 at 5, 1 at 7, 1 at 9, and 1 at 11. Because my shells are going to be from in these intervals here. Okay. So that would mean that x1 is 3, x2 is 5, x3 is 7, x4 is 9, and x5, because I'm supposed to have 5 shells, is 11. So what you would do is you would take these x values and plug them in to each one of these and evaluate.